And we're live. Okay. So, for those of you that are absent today and are watching this video via YouTube, in your emails you should find the beginning question that comes up for this next activity. That's the start of a journal entry for this particular journal. This would be the second entry in the journal for, I believe, for this unit, because obviously we just got completed with the first one. We just did a mass of unit cubes activity, and obviously now we're going to do an activity here shortly called the density of solids. And to start that off, we have a question. So to recap the question, and to do our instant poll, Sam put a solid ball in a tank of water, and in the diagram you guys saw two balls in a tank of water, kind of looked like a fish tank. So the left ball was about halfway submerged. The right ball was about 3/4 submerged. So the right ball was a little more into the water than the left one. What can Sam do to make the ball on the left float like the ball on the right? Again, so Sam wants the ball on the left to sink a little more and be exactly like the ball on the right. So you guys are asked to check the box next to the things that Sam can do to have a solid ball float so that most of it is below the water level. Okay? So that was your test. So time for the instant poll, which means either heads down or close your eyes, something like that. Okay, so obviously with each one, you didn't have to answer each one. You could check any one of them that you wanted to, but I'm figuring that you won't obviously have all of them checked. In fact, you shouldn't have all of them checked. I'll tell you right now, you're wrong if you have every one of them checked, because you'll have pairs that contradict each other. Okay, so the first response is use a larger ball made out of the same material. Please raise your hand if anyone answered the first one, which is to use a larger ball made out of the same material. Please raise your hands high so that I can see them. And you can put your hands down. The second response, use a smaller ball made out of the same material. Please raise your hand if you answered the second response. Okay, you can put them down. The next response, use a ball of the same size made out of a denser material. Please raise your hands if you chose the third response. You can put your hands down. The fourth response is use a ball of the same size made out of a less dense material. Please raise your hands if you chose that response. You need to keep your eyes closed, please. You can put your hands down. The fifth response, add more water to the tank so that it is deeper. Raise your hand if you chose that response. Put your hands down. The sixth response, add salt to the water. Raise your hand if you chose that. You can put your hands down. And the last response, attach a weight to the ball. Please raise your hand if you chose that response. You can put your hands down. Okay. So to let you know the results of the instant poll, very interesting, okay? There were 3 responses that were all the same popularity, and then another response that only was 1 away from it, and then there were 3 responses that had zeros on them. So just to kind of give you the zeros to start with, 2, use a smaller ball made out of the same material. No one responded to that. Add more water to the tank so that it's deeper. No one chose that. And no one chose add salt to the water. Okay. The second most common response, I guess you could say, was this: attach a weight to the ball. 4 people said that. And then the other 3 responses were all a tie. There were 5 votes for each one of these. For the first one, use a larger ball made out of the same material. For the third one, use a ball of the same size made out of a denser material. And there were 5 for this one. Use a ball of the same size made out of a less dense material. Okay? So, those are the results of the instant poll. We'll see how that changes as we go through this activity and do others. Okay? So with that, we'll turn off the projector and go over what the directions are for the activity first. And once we get the directions for the activity, I'll shut off the camera and then we'll draw marbles for partners and do the activity. Here come the lights. Okay, now, in your group, you're going to be given 5 pieces of the same type of metal. They'll look obviously like this, but obviously they'll differ in size. So you'll get 5 pieces of the same type of metal, but different lengths. Okay? And what I want you to do, just like before, is find the mass of the material, find the volume of the material, and that'll be all that you'll need to do with those objects, at least in the lab part of it. When you are done gathering your data for those pieces, if you want to, what you can do is, I do have some different objects in here. And then what you could do is find the mass and volume for any of these other types of gadgets or objects that I have in here. Okay? Because what I'm going to have you do with the metal pieces that are of the same type, obviously different sizes, is obviously you're recording the mass and volume, and then when you're done with that, I'm going to have you in your groups get on your computer. And from what I understand, I believe the machines that you guys have should be loaded with a program known as Logger Pro. Okay? And I'm trying to remember specific, isn't there like some type of program on your computer that you can update your computer with? Now, if it's not on there already, I can help you search for it and find it so that it gets added onto your computer. But anyway, you're going to take and you're going to make a graph with this information. We're on that graph. You're going to put mass on the y-axis, volume on the x-axis. And you're going to want to make sure that you label your graph with the appropriate units. Mass for grams. And actually, I'm going to hold off on the units for volume because I've got another question for you there before I do so. There's actually 2 ways that we could take and measure the volume of this piece of metal. One way I know you already know about because we did it just the other day with the cubes. So, how are you saying that you can find the volume of an object with just measuring with a ruler? How did you find the volume of the cube?
Length times width times height.
Right, length times width times height, also known as area times height. So you've got to find the area of the flat part of your object and multiply it times the height of the object. Well, with something like this, what type of a shape is this object? It's a circle, yeah, cylindrical. How do you find the area of a circle? Pi times radius squared. Okay? So pi r squared times height gives you the volume of this if you want to do it with a ruler. If you don't want to do it with a ruler, there is another way. Think to what you just saw from the beginning question. In that beginning question picture, what did you have? What did you see in that picture? What was in the picture?
Wasn't it a cookie?
No. What was in the picture I was just showing you for the beginning question?
Oh, ball. This is
Yeah.
the beginning question.
Yeah. Balls in what?
Water.
In water. What happens when you drop an object into water? It floats or it sinks. Okay, if it sinks, what do you notice happens to the water? It moves up. Yeah, it does. It does. Okay, so if I put some water into a graduated cylinder, and then my water level goes up when I drop the object in. So say here's my graduated cylinder. Let's say I've got a water level right here to begin with, and then it moves and it goes up to here. So when it rose from here to here, what do I got to do with those two measurements?
Subtract them.
Subtract them. What's that difference representing?
Volume.
You got the volume of your object. Very good. Okay, so there's two ways you can do this. You can, if your group is comfortable and wants to do it with a ruler, you may. So then, if you do it that way, your volume needs to be in centimeters cubed, if you do it with the ruler. But if you do it with a graduated cylinder, and you find the difference between the two watermarks, what do we measure volume in the metric system? Think about a big bottle of pop, those really big bottles.
Meters.
Liters, yeah. What's the smaller unit from liters? Huh? Milliliters, yeah. Okay, so these graduated cylinders will measure in milliliters. So if you go that route, your volume measurement needs to be in milliliters. Okay? And there may be another question, well, Mr. Knoll, aren't those units a little bit different? We'll cross that bridge when we get to the end. Promise you that, okay? And then when you're done with the 5 different length objects, again, come and find some type of an object that's obviously different from that, and then just see if you can find its mass and its volume. Obviously, they're not perfectly shaped, so you may just want to do the water method with that particular one. Okay? So I've got different shaped rocks, I've got paper clips, I've got nails, etc. Whatever you want to choose. I've also actually, Mr. Unwin did this activity with his college class at Hawkeye. I think it was like a Project Lead the Way class, and they made some different size little blocks. If you guys want to try one of the different size little blocks, you feel free to use that too. Okay? Questions on what you are doing in this lab activity? Anybody? Okay. that's where I'm gonna turn off the video right now. We'll do the lab activity. Obviously, we gotta draw for partners first, so we'll get partners drawn and I'll get you guys started. I know you don't have a ton of time, but what you can at least get done for today to start with is, I bet you can at least get your objects and start getting the masses of them. And then maybe tomorrow you can start getting the volumes, or vice versa, whichever you want to do first. Maybe you can just take one object, find the mass and volume. If you got time to do a second one, and so on. Okay. That's all for the video today. Goodbye.